Hi. Let's get some tunes going on here. Oh my god, that's really loud. There we go. That seems good. There we are. Hi, welcome back, by the way. So some progress has been made since we were last hanging out. Welcome. Let's dive into our progress in just a second here. Cool. So if you're coming back to us, welcome back. We'll call this part 1A or part 2 or whatever the case may be. If you're looking at the title on YouTube later, it's what it is. This morning, we had some hang-ups. We were trying to figure out how to get the right lip profiles for the diameter that we're using, and we're having some issues with brake clearances. So I did a bit of research. I went off the stream and just did some digging into some information, talked to a few people, made some phone calls, and got what I needed. So to understand our conflict a little bit earlier, our lips and our brakes were conflicting, and I had no information of what sort of scale of reality we were in. Could we make the lip bigger? Could we not? And since I'm not manufacturing the lips, I didn't really have those choices, if that makes sense. So I made some phone calls, and I ended up talking to our lip manufacturer directly to find some guidance. One second here. There you go. And so the guidance I got was that our smallest lip can actually be 1.5 inches. So our front lip, so if we have the face of the wheel, we have the bolts coming in from the outside, we have the front lip, here we have the tire. It can even be as small as 1.5 inch for our 15-inch wheel, which is great. And then the rest is going to have to be made up by the back of the wheel. So that'll be a 6-inch rear barrel, a 1.5-inch front barrel. No problem. Additionally, they gave me the clearance. They gave me a measurement of the internal size of our wheel, our rear lip diameter, which is 14.5 inches. So turns out that our brake caliper is 180 from the center of the hub out to the furthest point, 180 millimeters, which turns out to be 360 millimeters if we rotate it around. That's about 14.1 inch. So the fact that we have a 14.5 inch clearance on that is going to give us some leeway there. So that was kind of the big benefit, the big bonus of making that phone call. So yeah, I've updated since then. I've updated our sort of checklist here, that our current conflict, and we actually had a solution. We called the manufacturer. We had our inner brake clearance, and we figured out a small slip. So we can now update the drawing. I already started doing that. I was like, wait, I sort of need to stream this. So yeah, so I've started making a drawing here of our updated stuff. So essentially this lip profile that we have here now is trash to us. So we're gonna have to make some changes to that. So let's do those changes. Let's delete this guy. There we go. So let's make some changes to our drawing here. Since this is garbage, it doesn't really apply in this particular situation. I'm going to delete a lot of this. It's going to get hecked off. See you later. Awesome. We've got our offset here, which is great. All this is set up really nicely. Actually, let's do this a little bit better here. So, hack that off. Let's see what we want to delete here. Yeah, this is roughly what we want to delete. Cool. So we've got a rough idea where we got to be. So, let me show you what I got. Let me share with you what I saw with my own eyes, so you can kind of know what's going on and what changed my brain. Because I was feeling very frustrated at first. I'm back to not feeling frustrated, and it's all about information. The more information I have, the easier decisions are, if that makes sense, and the better where that information is organized. Now, I learned a different way than maybe other people would learn. I need to see photos of things to sort of understand and plan out and how things move. So I'll share with you the photograph I got to see. So this, although a very little photograph, is really what helped me out. So this is actually a 15-inch rim, and he was like, hey man, we got 14.5 inches of brake clearance. And I was like, cool, where? Because it could be really close to the face. Like, this is the back of the wheel we're looking at. It could be really close to the face of the rim. It could be really close to the very back edge of the rim. And so he was like, no, it's almost nearly a 90-degree or flat surface all the way across. And yeah, it's about 14.5 inches of clearance. So seeing this photo of another rendering he's done for his clients, for his lips, gives me a lot of more information. Additionally, it shows me the way the wheel will step here. So I can plan out how the bolts are going to interact, if that makes sense. Really do need to plan those out, because our brake actually sticks out further than our hub mounting surface, which can be a conflict if our brake caliper clips or hits that. So we've got some opportunities here. Sweet. Now, if you're hanging out, if you're watching our stream, that's cool. Most of this stuff is for the YouTube, but you're welcome to join in with me while we're doing this. That's kind of the whole purpose of this. So, knowing that we have those opportunities, let's keep that photo up, because I'll use that in a bit here. So yeah, I've sort of planned out our 1-inch. You know what? I made a mistake here, so. Now, this lip is not going to be accurate at all, and it's totally okay. This lip here is specifically designed to let's trim this boy. There we go. No, cancel. There you go. Let's move this guy here. No. There we go. Sweet. I'll delete that. Control V, and I'll move those entities from here to annoying here. So there we go. Awesome. So let's plan out our we're going to make up a lip here. And you're like, why would you make one up? Because I have approximately the information I need, and although more information would be great, we can work with what we got. Nah. We'll delete that. We'll fix this for now. This one should get longer. Nope. Heck you, pal. I can manually drag it out, but it doesn't want me to. Stupid. Okay. No. Keep it roughly the same. There we go. Sweet. We'll give this 0.2 of an inch radius. There we go. That should be roughly right. Now this one's interesting. We can use this. What I'd like to do is we'll save this. And let's open up some hardware. I need some hardware because we're going to be running some M8 hardware. And I want to know how much roughly we can see in our diagram here that the step is big enough to consider the hardware. So we also want to consider the hardware. And so let's dive in here. We'll get into some hardware. There we go. And I think I have an M8 nut that we can go by. This is roughly a correct M8 nut. So evaluate, we'll measure this guy up. He is 0.7 of an inch. So let's see here. Diameter. So we should be able to find this next one should be 7 of an inch. Cool. There we go. Now, step looks roughly the same height as that nut. So how tall is our nut? How tall are your nuts? How tall are those nuts? Are they tall nuts? So 0.31. Let's go from here. 8 millimeters? Okay. 8 by 8, I guess. This guy should be 8 mil. No, why does it always pick that one? Like, god damn it. Now this guy here, we're gonna get him offset of, there we go, delete this guy. Heck him. Heck him. Okay, done. There you go. We have a rough lip setup. This is really rough. Rough bark, 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 rough, 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 rough. Rough, rough, bark, 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 bark. I'm gonna call this super rough. Rough, bark, 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 bark. Okay, we got a rough lip setup. It's ugly, but she do. Alright. So not only do we know where to like flump our face down in here now, but we can save this. Oh yeah. So this is exciting. We've got a rough idea of like where our face is, where our lips are going to be, and how our brake's going to clear. All the good things. We want all the good things. We need the good things. We need the good stuff. We're going to edit this just a little bit more because we're missing a little. No, we're good there. Okay, file, save. Let's do an experiment here. Feature revolve around base, and we'll select our axis one, and it should give us the looks of our lips. The lips of our looks. Look at our lips. Them's bees our lips. They're ugly, but they do. And to give you some context to see if we are correct, you can take a look at our estimated estimate, which is estimated, and just an estimate. But a little bit of difference in the inner lip, but we should get away with this just okay. Perfect. All right, let's yeet that beat, because we don't need that beat at this moment. All right, I'm nervous and I'm saving. Okay, we can actually move on to our 5, 5, and 5, which I'm very excited. So our first goal here is to create 5 really rough structural things. So really, really basic structural concepts that will fit, that we can stress test. So what I want to do here is also, I've got to add in some more. We're missing a little bit of information. Let's add a little bit more hardware in here. So we're going to add in our drill shape. Drill shape. Cool. And then I think our template will be complete. There we go. Okay, we can hide this for now. We'll come back to it. If you're watching, thanks for hanging out with us, by the way. We're designing our Miata wheels. These are a performance wheel. They're not specifically a stylish wheel. They're about getting the lowest weight at the highest amount of function. So, okay. I'm nervous. This is nervous. That makes me nervous. We're going to start off with something really basic to start with. We're going to start with a super simple spun shape. We want to create five basic shapes. So I've got a couple in my brain that I want to do, but I've got a couple I don't know what I want to do yet. So that leaves us opens for some options. So let's start with some basic ones here. And it's okay to fail with this. We might end up making 8 or 10 and then pick 5 from there to stress test. Brainwave. Endorphins. I love this shit. This is the good shit. It's the good shit. Okay, go to our right plane here, and let's start sketching. Just creating that flange that will bolt the wheel to. This flange height is variable. We can that is undetermined. That flange height is more determined by the stock that we buy, the round stock, than anything. Also, why music do weirds? Okay, you just changing songs. I wish the songs were longer, not these like 4-minute songs. Side rant. Okay. So we've got all this room to play with in regards to our brake, which is fun. There we are. So here is a really super simple basic shape. You're like, Quinn, I don't see nothing. I just see a weird thing. Let's make it a thing. Awesome. So we've got a really super simple face here. This, with some drill holes in it, would be all we need to do to make a rim, to make a wheel. But we can probably save some weight out of this. This is already looking pretty chunky. To give you an example, we're going to set the material here. I'm going to assume at this point, we're not entirely sure which material we're going to be using, but I'm assuming we're using a 6061, which is kind of a soft aircraft grade aluminum. If I was looking at the aircraft grades, it's one of the softer ones. If you get into a 7075, a little bit harder, doesn't matter. Softer is usually lighter, but not as strong, but also a little bit more... like a 6061 would flex. I know aluminum doesn't flex. A 6061 would deflect a little bit more than a 7075 before like tearing or anything like that. It's just a little bit softer, just a bit. Okay, so yeah. Okay, let's do some basic cutouts on this borch. So let's go on our front plane. Let's Let's cut them. Ideally, we want the most amount of strength with the least amount of weight. So, we were looking at how chonky this boy is. Okay. So currently, our boy is pretty chonk at 3,041 grams. For you YouTubes. Yeah, we're looking at a 6.7 inch, or 6.7 inch pound. 6.7 pounds for the center. That is meh. We want to add a check mark to our template. Hell yeah, we did it. Splash. Hit you with those endorphins. Hell yeah. Okay. So that's chonky. We don't want it to be so chonky. Too chonk. Many too chonk. So we're going to create a really basic rough basic wheel. This is the whole purpose of this, is to be crude and rough with this. Also, I hate that. I hate what I just did there. Okay. I hate it. There we go. Now we're cooking with gas. There we go. Tell these guys to heck off. Also, I effed it up, which is fine. Trimmed away the wrong bit. I'll trim this one. Cool. Delete that. Yes. No. There we go. Okay, let's... Let's do this in 10 mil. I'm a fucking idiot. Okay. Yeah. No. Discard changes. Okay. I'm retarded. That was absolutely retarded. I can't believe how ridiculous that was. Okay, welcome guys. If you're hanging out watching us doing some design stream, this is part 1 to AA4-913 of our design stream. If you're not sure what that means, it means we started this morning. I had some hang-ups and we had to restart again. So you can consider this part 2. If you're hanging out with us, good to see ya. If you have questions about automobiles in general during our stream, please always ask. I don't mind being distracted from this. If you have a question burning in your loins, deep down, I couldn't believe the loins they burned. If it's there and you need the hand, you don't know what you want. Okay, let's do yeah. See ya. Wouldn't want to be ya. Sweet. Yes. Twim. There we go. We're doing some super simple shapes. This particular step of our design process is purposely meant to be crude. There is no other reason for this not to be crude. There we go. We're getting a very crude shape here. Look at that. Ta-da! Awesome. Woo! Ooh-ah. Ooh-ah. Oh, have a night. Okay, we'll do a circular pattern on that. And we'll do 4 around axis 1. There we go. You're like, wow, that looks like a wheel I've seen before. There's been a million wheels that look like this particular one. This is going to be our rough design number 1. So file save as, part 1. We'll call this P1V1. So part 1, version 1. Cool. So we're going to stress test this at some point. I've got a separate computer to stress test stuff with, so I can set that up in the background and do some tests if need be. But at this point, that's where we're at with that. What we will do though, 2009 customers is. I forgot how to add a folder to sharing. Uh-oh. Uh-oh. Spaghetti-o. Ah. Ah, share. No. I want to share it to another computer. Dang it. No. You know what? We'll do it a different way. That's okay. Sweet. Okay. Bump-a-dump. All right. So we've got our super simple basic wheel here. Got some cutouts in it. Let's start again. You're like, what? Start again? Yep. Oh, dang, a duck. Duck Dangers, USA. Nope. Yeah, it's not there. Okay. Yeah, there we go. Cool. Okay. So let's try this again. Create another one, but let's cut out some different metal or material this time. Our goal isn't to get an optimal design on the first try. Our goal is to find which direction to go to optimal for. So with our 555 design process, we're going to just design 5 different really rough sketches, stress the shit out of them, and then go like, oh, you know what? This is the way we need to go with this, or we need to go the other direction. Whichever way is going to take us to where we need to be, we want to follow that. So we got to listen to the results, I guess. Sweet. Okay. This time, let's try something a little bit different. Let's go to our front plane. Let's maybe sketch something like this. Cool. Now we're going to sketch something like this. Go. Oh, cancel. Actually, you know what? Yes. There we go. I go circular pattern. Look at that. Ta-dung. Okay. We're also maybe add in. Check this out. So let's. Nope, that's not what I wanted. We want to do this as an offset entity. We'll reverse the direction. Delete that reference. Nope. Yeah, this can be its own boss. That's so good. We don't need you to constantly tie everything together all the time. Yeah, that's what I want. Sweet. So this is a really shitty shape. I'm gonna be honest. This is not great. This is of poor quality, I would even say. But we can stress it out, and we can see how it likes it and how it doesn't like it. We will add in our edited sketch. Actually, I think this one should be okay. We can probably be okay with this. So we're gonna do a revolve cut with this guy here. Cut out just fine, and then using that revolve cut, we'll do a circular pattern around our axis here. Awesome. So we've got roughly a shape number 2. So we're going to call this P1 V2, 2 out of 5. Cool. Awesome. Let's dive into more. Sweet. Cool. So we're working on to our next design here. Now, let's see if we can change this up a little bit. So what I'm going to do is I'm going to do something maybe that I feel is less strong, because maybe I'm wrong. Maybe I don't know exactly what might be the strongest shape. And so let's take the opportunity to be wrong, if that makes sense. Go. But yeah, one of the best things you can do in design is to show mistakes. A lot of people are like, oh, I gotta present the perfect thing, but the person you're presenting this information to hasn't taken the journey that you're taking, and so they might not understand why you come to conclusions. So let's design something that's maybe really heavy, or maybe is too strong for the situation. Being too strong is actually a problem. It's a waste of resources for the most part. You put all this time and effort into creating this, but maybe that's more than it needed. Yeah, and so it's kind of more appropriate to make those mistakes, do it wrong, and then find out ways, like show the other ways that were better. So yeah, we're gonna make some mistakes here, and we're gonna F it up. Let's see here. Okay, we're gonna delete that. There we go. That's the one I want. There's one specific design that's in my brain that I really want to try out, and it's going to be a little bit more complicated than the rest. That's not this one, but I love how you're like, hey man, I deleted that offset reference, and it's like, no, you didn't. And I'm like, I'm pretty sure I did. It's like, nah, you didn't. And they're like, oh, okay. I'm pretty sure I did. Nah, you didn't. You didn't. Oh, okay, cool. I guess. There we go. Put the thing so far. Oh, nope. Nope, I'm out on that song. Oh, boy. What's the deal? What's the deal with hamburgers? Yes. There we go. We got a rough shape here. Maybe this is a better one. Maybe it's a worse one. Who knows? We'll add this to file save as. P1 V3. So that's 3 of our 5. Really rough, basic shapes here. Oh, you know what? I need to do some more work on this one. So. There we go. Sweet. Arnold Palmer for design days. Okay. Lettuce. A big head of lettuce. Delicious head of lettuce. All right, I'm gonna create that one that's in my brain. This is gonna suck, by the way, but let's do it for sport. Indazar, welcome. We are working on a 3-piece Miata performance wheel. Come on. There we go. I don't know if I'm happy with that. You know what I'd like to do? Let's do this a different way. Yes to all. See you later. Let us create a better context. The better context. Wheat. There we go. And we'll create an offset. 15. 20. 20 is fine. Okay. And this can be longer. Shall trim that entity. We shall trim this entity as well. And let us eat cake. Let's make this a 20. There we go. Top support. There we are. We can feature extrude this bad boy. Bad boy. Let's do a wild amount. 50 mil. Welcome everybody who's hanging out. Good to see ya. Now before we chomp this bench out, we're gonna do some weirds here. We're going to create a new plane. This is getting a bit strange. This is the strange one I wanted to work on. Just for sport. Purely for sport. On this plane here, we're going to sketch some sketchy. We're going to do some sketchy. Let's sketch up our sketch. So, yeah. Ish. There we go. And let's give us some... You know what we'll do? We'll do this. There we go. Quinn, what the hell are you doing? Trash. We're working on trash, really. Yeah, why not? Okay. That'll do. There we go. And then we'll do this. Local garbage in your area is local garbage. This is not a good design. I'm not saying it's a good design. It's just a design I want to do out of my brain. Okay, let's make some adjustments to this guy, though. Yeah, that's good. We want to adjust this guy here. So let's move this guy up a bit here. Move this guy up a bit. There we are. Do I like it? No. Am I going to use it? Yeah, a little bit. Okay, where's this guy got his pivot point? Now this guy's gonna come in just a bit. Sweet. And we'll bring this guy out just a bit more. Nope, we gotta make that smaller. It's gonna take a little bit of tweaking here, which I'm okay with. I'm not happy with this. Not happy with it. Why is this locked? It's fully defined. I want it undefined. This will do for now, I guess. All right. Whoo, she's an ugly design. Whoo, she's ugly. Look, I'm aware. Welcome to the stream if you're hanging out with us. Good to see you. I'll offset them 5. Here we go. Extruded cut. And we'll come in maybe 40. 6 degrees? Yeah. Oh, she's ugly. There we go. We'll fillet this stuff just for sport. Oh yeah, how to design the ugliest wheel possible. Hey Quinn, what would you like to do? I'd like to really design an ugly wheel. Oh, no problem. You can do that. We've got the skills and the setup for you. Ooh, she's ugly. Yeah, let's get this a little bit more over here. There you go. Now you can be a little bit more intimate with me. Hi. Oh boy. This sucks. Let's have fun with it. There we go. Got a rough boy. Now, there's a weird cut I want to do. This is where it gets abstract. I have some dreams of mine that are relative to some hub cooling ideas, but it's going to be tricky to pull off. All right, we got to first create. We got to create problems. Number one way to solve your problems in life is to create more problems until you're dead. Thank you, Wolf Puppy. Let's fillet some stuff here first, so that when we cut stuff, it's not going to be harder to fillet later. All right, we're in. Let's do it. Okay, so right plane. We'll chop this bench. Yeek. This sucks. All right, we're gonna create on our right plane a sketch, something like that. Yeah. Okay, nothing wild, nothing crazy. Control C. And then on plane 3, we're going to add in there. Cool, so we should have enough information to create some reference geometry using a plane. Look at that. Ta-da! And now, nope. I like the other normal. We're going to sketch on said plane. Quinn, what are you doing? Madness is what I'm doing. Okay, features, extruded cut, blind through all. It's madness! Okay, let's adjust this cut. Now, let's adjust this guy here, because he can draft outwards. We'll leave him there, but we're going to make some changes to our sketches here. So we had some sketches, and this guy needs to be more parallel to that. There we go. Continue with error. Alright, let's delete this. Yes. Totally okay. This one here, that sketch has got to get yeeted. Oh no, this one's the unit that needs to get yeeted. Delete. There we go. Now on, we're going to copy this one, Control C, and then on to plane 3, we'll Control V. There we go. Now we can define our plane, and we'll try again. Let's do some sketches. So we're kind of getting there. Yeah. Seems a little wild, but them's the breaks. Cool, so lettuce. A delicious head of lettuce. We'll delete that. There we go. Maybe we'll try this one separately. We'll do a fillet separate. Maybe we'll do 5 mil. Do it like 5 mil. Is he gonna get mad at us? Who knows? 1 mil? Okay, so if we select both, does it do both? It's thinking. It didn't like 5 mil. Okay. 2 mil? Do a think. You come back to me on that. It liked 1 mil. So we'll just do 1 mil. That sucks. I want to do more than 1 mil, but you know, here we are. Okay. So we're going to circulate this pattern, and we're going to use our axis here. It don't like that. It doesn't want me to do this. It's like, this shape is tough. I'm confused. I get it. I understand. It can be very confusing. Which is fine. That's why I'm going to force the program to do what I want it to. So that's not stupid, though. But before we do that, stupido, we're going to do this. We're going back to our loft. There we go. There we go. Top Sports. Top Sports USA. So she's an ugly wheel, but she's a wheel. All right. In a moment, we're going to get into telling this duder about life. Can we go bigger now? Hell yeah. Hell yeah. Although we have some conflicts of interest in regards to putting our inserts in. That's okay. We'll still we can redo this design and make some adjustments to it. This is just the preliminary stage, part 1 of a 3-part series. All right. I want to chomp it, chomp. And then I want to spin. And I want to do some sketching. Sketching! Okay, this boy here. I want to coincident with that. But I also want this guy here to sort of... I don't know, man. I can't really get the two to interact. It's not really a lot I can do there. That's okay. I can make it do what I want it to do. Through sheer force of will and anger. My name's Will Anger. Stupid jokes by Quinn while he works. Alright. Yeah, maybe. Cinq. That's 5 in French. Okay, we do. Spin. Okay. Now we can fillet. Fillet? You do 1. You do 2. You do 3. Nah, you do 2.5. 2.5? 2.5. I do 2.5. Top Sport. Cool. Spin. Okay. Other thing we want to do is we want to do some chomping. Chorp it. Cranch it up. Does this guy, is he real? Yeah, I'm real. I'm sorry. I'm sorry about the way I talk. Not really sorry, like not super sorry, but a little bit sorry, I guess. Okay, we're going to do some revolve cuts around some axes. Yeets. You've done a yeet. Alright, last but not least is we want to... And this is not the last. I thought it was the last. It's not the last. We're nowhere near the end. This one's pretty involved, though, I will say. Yep. Sweep. And we can even do this Top Sport. Where's my hidden boy? You. Do a revolve cut. Secrete the yeet. All right. Sad boy. Yeah. So I can already see some major failure points here where this thing is going to stress out and get mad. And it's mostly has to do actually with the bottom of our spoke design, but that's okay. Again, we're looking to adventure. Oh, we got Shagnar. So we got the Speen. I like the Speen. Welcome, welcome. We also have the Ghost Nick. Good day. We were borking at me. I appreciate the borks. If you're just joining us, we're working on a 3-piece Miata wheel for a customer. But we're kind of doing a new design method. So we're using what's called a 5-5-5 design method. So we're doing 5 rough structural designs. We're going to stress test those designs. Then we're going to do 5 refined versions of whatever one essentially wins the stress test competition. And then we're going to stress test those 5 refined versions. And then from that the winner of that one, we're going to do 5 aesthetic versions. So versions that like we're going to change or update the way it looks. So these are actually these are 19s. These are 15s. However, we're using an American-made barrel. And American-made barrels come in only 2 sizes, 13 and 15. However, the reason that it exists is due to autocross and the popularity of autocross, specifically SCCA autocross in North America. So anyways, no one makes 14-inch barrels in North America. That's just not a thing. I mean, if you have enough money, it's a thing. But the center for this 13 and 15-inch barrel is often standardized. So you'll often use a 13-inch center in a 15-inch barrel. So this is going to be a bit of an abstract looking wheel, but our goal is the lowest weight at the highest strength using locally sourced lips. This is not a Speed Hero wheel. This is for a client. And so this is more performance based than anything. So that's why we're kind of using our 5-5-5 design method. If that answers your questions. I don't know if it do, but if it do, it do. If it don't, I'm going to answer more of them. I would love to. That's kind of the whole purpose I'm sharing this with you. Well, actually, the major purpose is so that other people can see my design process. Because people are like, oh man, you can do that stuff in like a second. And I'm like, yeah, I mean, no. Just because I'm good at the program and my brain works well for it doesn't mean that my time is less valuable. Woo. Needs a center cap with a turbine. Actually, what I would like is a center cap that isn't turbined. It's actually got a gap in it, and it's got a scoop and a bearing. And so as the wheel goes by, the scoop will line up with the holes, and then the scoop will be facing the air coming in, but the bearing and the weight keeps it level all the time. Just like Toronto taxi cabs with the advertisement on the cap, the wheel will spin, but the cap will stay still. That would be great. That way the design we're working on right now is just to try to reduce hub heat, but this is beyond the need that we actually have. So I'm just experimenting for fun. Quinn, why'd you cut all the way away? Because I'm cheating the program into doing what I want it to do. Because it won't friggin' do what I want it to do. So I'm going to be like, nope, you're going to do what I want it to do. And it's like, oh, okay, I'll do what you want to do. Like, hell yeah. There we go. What an ugly wheel. Or beautiful, depending on what you consider as beautiful or ugly. Because I was looking at some SSR Mark II front-wheel drive, Mark II R, I think. They're completely different than SSR Mark IIs, but they have almost the same name. Like SSR Mark II R, I think. Let's see. Yeah, these guys are a rough inspiration. I mean, this is probably a pretty strong wheel design, to be honest. We're looking for high strength, low weight. The only thing that they do weird is they put the bolt holes in the wrong position, but yeah. Yeah, a bit chunkier. These, so to understand our 555 design sort of method, these first 5 designs are going to be really clunky. They're not going to be refined at all. The whole goal is that we can just get some stress testing feedback from a very simplistic model, and then our next 5 we'll take and make a lot more detailed. So this particular one is just a chunky boy I wanted to try out. There's already some problems with it that I can see that need to be dealt with. Like, it's going to fail right here, and it's going to really build a lot of stress and force right in this chasm here. So yeah, this boy's going to not do well in our stress test, but I'm having fun, and I just wanted to, I was sitting up late at night and dreaming about wheels, and I wanted to do this weird cut underneath the spoke. Cool. All right, I'll save as part 1, P1V4. The music today, so the reason the music's kind of like up and down and like good and bad is I'm using a free streaming service. That's also why our chat is spammed. The reason being is I don't want the audio to be destroyed on these. I want to put a compilation together at the end of like the whole process of designing these wheels, and so I have to sacrifice good music for lack of copyright strikes. Finding acceptable music on the internet that doesn't want me to pay money for it is nearly impossible, which is fair. I want to be paid for my services as well, so totally okay. All right, let's do our 5th design here. All of this will be milled. This is going to be, we have access to a 5-axis CNC. Some of these designs are unmachinable, so I understand that. We're just exploring the stresses of them, if that makes sense. So we're just adventuring across those, yeah, if that makes sense. All right, I want to create a 8-spoke. I want to create an 8-spoke. I want to create essentially a clone Watanabe just for stress testing purposes, not because we'll go the Watanabe way, but let's create a clone of a Watanabe just for fun. Yeah, a lot of this stuff is going to take a lot of cutting and fiddling and stuff like that. So this part of the step is just for feedback of shape. That's it. Like I'm gonna put it through a radial test. So we're gonna spin it, and we're gonna put it through a torsional test, and then from there we can build a more CNC friendly design in our next step. So this is just part of step 1. We're not quite getting into considering machining difficulty, because machining difficulty sometimes is also a hindrance to the quality of the wheel that you're. Yeah. So yeah. Sorry, I do have the time for the questions. Okay. Let's make bananas. Banan. We'll do this first. Chorp, 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 chorp. Chorp. There we go. Yeah, that last design is very aggressive and pointless. I'm mixing it in just to kind of mix it in. I want to create things. Let's create stuff. Let's make things. That'll do just fine for us. Let's hide that boy, though, because I don't need it. There we go. There we go. And then on our top plane here, there we go. You know what? I gotta make a new one. That's okay. Kind of a bit of a throwaway there, but that's okay. Here we go. Well, I don't like that it's easy to do, says the computer. Why won't you loft for me? You know what it is? I effed it all up. Okay. My references are confused. Actually, there we go. That should work better. We'll find out. Okay. Why does it hate my guide curves? What's your deal? Don't save. Try again. Holy trash. Holy trash. Trash. Thank you guys for hanging out, by the way. Okay, we're gonna... Let's create a new plane. Okay, there we go. Now on the right plane, we should be able to create a sketch that... Right. That's why... That's where it went wrong. Okay. I have to pierce the outside of the dang thing. You gotta pierce the outside of the dang thing. Typical. There we go. And that should work well this time. Alright, let's loft this branch. And then we'll use our guide curve. Now it's happy. There we are. Woo! Okay. That'll do. Actually, before we even do that, wheat. There we go. Top sport. Look at this great wheel. World's best wheel. Sure. Wow, Quinn, I've never seen a better wheel in my life. I know, it's the best one. Some of these are pretty ugly. General Wheel design. Look at me, it's General Wheel. I am General Wheel. The general of all wheels. Okay. Oh god, it's heinous. It's heinous! This is a true Watanabe. I guess we can fillet these guys here. That would be fair to the rest of the fillets. Kind of works. Okay, we got some rough designs, rough bark. This thing sucks. It's ugly as shit. Holy god dang. Gorsh dang, Bucky. Okay. Let's do our little bit of revolved cut here. This is gonna go really bad because I didn't plan this out very well. You know what? It's there. It's okay. Four is great. There we go. General wheel design. Hey, what'd you guys do? Well, I did general wheel. Okay, we've got 5 versions. Let's take a review here of our 5 versions to see if there's... Let's take a look here. So let's look up version 1. Super simple, super easy, super basic. Version 2. A little bit more complicated. Version 3. Okay, a little bit less complicated, I guess. I don't know. Got version 4, which is the ultimately wildly way too complicated version. And then at version 5. Out of curiosity, actually, let's file. Can we open all of these? We can definitely move on from this pretzel song. There we go. Okay, so if we're looking at the weight of these, let's take a look. Let's evaluate our mass properties. You have 1,300 grams. Let's save this stuff, actually. So the first, version 1, we have weight, and actually let's delete this stuff. Let's try this again. 1, we have weight, strength. These guys can be go Triple C, B. To V3, V4, V5. Okay, so we've got our versions here. Let's take a look at what our weights are. So let's go into, we got version 1. So our mass here is, we're looking at 1,900 grams. So let's throw that in there. That's version 1. We can close that up. Let's take a look at version 2. We'll do our mass here at 1,800 grams. There we go. So this is version 2. Let's get into version 3 here. We've got some mass properties in this guy. He's a chonky boy at 2385. We got version 4, which is absolutely wild. He's a light boy at 13. So we got 1,300 on him. Ooh, he's a light boy. Now we got version 5, and what's our mass properties in this? 1,500. Now, obviously, there's plenty of room to save weight in this particular design. But if we were to start cutting weight out of the center of this, it actually would affect the structure of this. So there's some ways we could move the weight around to add some structure, but it might actually get that much lighter, interestingly enough. So we've got some weight here. There we go. Cool. We got to move on to the hard part now. The hard part is going to be doing the structural tests. So I'm going to have to switch to my other computer here. But in the meantime, it's just going to be mostly me moving files around and stuff. So if that's boring, heck off. If it's not boring, you can hang out and we can talk and we can chat some more about cars. I'd love to talk to you about cars. So you know it feels good if you're hanging out with us. Sweet. Okay. So let's organize the other computer. Got to move some stuff across some drives here. There we go. Network. There we go. We have okay, we got some sweet. Awesome. So I'm going to set up some stress tests here for us. It's going to take us a couple minutes. So chill out. Enjoy. If you like the music, check out the website. If you don't, that's okay as well. Okay, so we want our simulation. We want a new study. Cool, and we're gonna start there. All right. So the first things we need to do is we need to build a virtual wall for this to connect to. So oh, I know what I effed up here. No, I didn't. Never mind. Virtual wall. There we go. And then we're going to use our right in here. There we go. We got some. Got to create some fixed geometry here. So basically, what we're doing is we're creating a virtual hub in SolidWorks. Sadly, you won't get to see this because I got to use 2 computers to do this. And then we're gonna bolt that wheel to that hub, and we're gonna try to flex the outside. So we're gonna try to spin the outside and try to flex it over as well. Am I doing this the way I want to do this? Let me think here. I'm not. We have to make some changes. So I've got to delete those files. Let's see. Which is totally okay. We're going to delete the files that we just installed. Yeah. There we go. We're going to try this again. I'm going to go through our files here. And we're going to add some lips to them because we want to stress the lips. This won't be a super accurate way of doing this, but it'll be somewhat better, more accurate than desired. There you go. File save. Open up our version 4. Save. Version 3. This, my friend, is why you build good file structures, so that you can quickly do jobs when you make mistakes like that. Okay. So go back to Speed Hero. We got customers here. Awesome, we can do this now properly. Nani? Okay, other computer's freaking out. Static study here. Let us create a virtual wall. Create some fixed geometry. Go. Now we're going to just turn for these tests we're going to use 10,000 Newton meters, so just to make it standardized, I guess, and to essentially overexert the wheel. So we'll do it on this plane here, and we're going to do it on this plane here, and we're going to spin it around that axis. Okay, so we're going to mesh and run. All right, we're working on our very first of 10 stress tests. I'll share the results with you here, if that makes sense. Meow. Meow. Cool. So we have one stress test done. Right. Go and go this. Go. Print screen. Paste. Alright, that's our first one of the bunch. We'll take 2 screenshots of that, just to make sure life is great. Okay. So for our updated list here, we have one. We need 2. All right. Let's call this. Ugh, stupid keyboard. Dash 1. Save and. Okay. So if you're wondering how our stress test turned out, I'll show you on our screen here. So this is our very first wheel that we tested. This was version 1. This is only a radial test at this point. We have not done a torsional test, but this is our radial test. And as you can see, we have a little bit of stress, especially built on the sides, right beside where our cutouts are for our pressed in lug nuts. And actually you can see the most amount of stress gathered down in where those lug nuts are being pressed in. So that's interesting to note. That maybe cutting our lugs in actually does damage our potential strength. So yeah, that's just to give you an example of kind of what we're doing. So we're going to copy that study. Duplicate, yep. And this time, we're going to change our axis to axis 2. And we're going to mesh and run. Cool. We'll see how our torsional test goes this time. So before we were twisting it this way, now we're twisting it this way. This information is just if you wish to participate in this, so you can skip ahead if you need. Welcome to part 2. Sweet. So we've got some information from that. Okay, we'll do a print screen. Save that, and Let's just say what I think it said in the song. Cool. So if you want to see where we're at with this here, so we just did our torsional test rather than our radial test. I don't know if that's the right word for those, but that's kind of what I'm calling it. And again, you can see a lot of collection of forces around where our wheel is bolted to the car, where the holes are drilled specifically for the wheel holes. So you can see our radial test here. We've got some tension along the side of the spoke here, and you can see in our other test here we have some tension building right at the edges of these guys here. So you can kind of see a bunch of stuff happening here. Interesting to note. Okay. Awesome. All right. So let's move on to our next wheel. We've done 1 of 5. Let's see here. All right. Okay. So we're gonna have open. Cool. I'm gonna create a new study for this wheel. Yeah, there we go. Again, we're going to use 10,000 Newton meters. Sweet. It's going to mesh and run here. And we're going to output soon. Ooh, this one's taking a little bit more time. There we go. All right. So we'll do a few images. Print screen of that guy. Two, 1, 2 dash 1. I'll do this. Cool. We're going to try again. We've changed it. We've done our radial test. Now we're going to do our torsional test, I guess. And the words aren't quite right, the right ones, but yeah. Sweet. once this wheel's done, I'll share it with you guys. Cool. So I'll show you guys here. If you're curious to where we're at. So we just did our second wheel. So this is the way it dealt with our radial test. So you can see a lot of buildup here of stress in the corner there. That sucks. That's potentially a shear point. Now, the part I'm actually more worried about is the other corner. So you're like, wow, that's a lot of red here. But this corner here is actually worse. Here's why. Things under tension are generally stronger than they are under compression. The best way to give an example of this is a piece of rope. If I tug a rope, it's stronger than if I push it. And so although this looks like a bigger collection of red, this is under tension. It's being pulled, where this is being compressed. This is our true failure point here. When that fails, yeah, the inside of this curvature here is going to have some tension or some compression, and then the overall thing's going to fail. So yeah, that sucks. If we, yeah, and you can kind of see it there. Again, where it's being compressed is where I'm more worried. That's a sharper amount of color there. So you can kind of use that as an example. Let's say I have point A and a point B, and I have a very smooth fade. That's much better than having a ton of blue and then having a sharp piece of red. I'd rather have the distribution of forces spread over more material than in one location. So this is a shit wheel. Again, we can see some really sharp points of concentration here, which is bad. This is our torsional test here, not our axial test, but our rather torsional test. And yeah, you can see there are some sharp points here. So this is a shit wheel design. There's some areas here that are really strong in blue, and this basically means there's too much material or too much metal here and not enough in this area here. So, ta-da, that's our second of 5 wheels tested here. In a couple minutes, I might need to take a break just to use the washroom and to eat a little bit of food. So, just know that. Cool. Let's move on to our third wheel here. Teach a man to fish. Let me tell you what. Again, we're going to use 10,000 newton meters just as an extreme. There we are. Meshing around this. Just gonna grab a washroom real quick. I'll be right back. a thief. Local thief steals my chair. Okay, you can join in the fun in a second here, Bentley. This guy stealing my chair while I'm gone. What a jerk. You can come snug though. You're invited. Yeah. Totally okay. All right. Did our music die? There we go. Sweet. Whoa, we got some bits. Ooh, Mr. Mike's giving us some bits. Thank you very much, sir. Welcome to the stream. I'm back again. My apologies. I was going there. So we're just doing some stress testing right now. Sadly, I have to use a separate computer, so you can't quite see what I'm doing, but I'm kind of sharing my results onto this computer here. So a little bit complicated, but not too bad. The more complicated part is there's a cat on my lap now, making it more difficult, but that's okay. He is welcome to be here and hang out. So we're gonna print that screen, and we'll paste it here. I'll save as, and this will be wheel number 3. So this will be Bontley. 3-1. There we go. Yeah. Okay, let's do another one here. Let's do another screenshot. Screen. Paste. So in a second here, we'll finish up these stress tests on the third one, and I'll be able to share those results with you. We're going to create a duplicate here. Go, and we're going to change our torque axis to axis 2. We're going to run this whole thing again. There we go. Mesh and run. Sweet. Awesome. Thanks for hanging out, by the way. If you're hanging out and watching us. What we're working on, if you have just joined us, is we're working on a Miata 3-piece wheel for a motorsports application. So this is not about designing the most beautiful wheel, but we're designing what we possibly could be the strongest wheel with the lowest weight. And we're trying to make it fit lips for 3-piece wheels that are very attainable for us. And so yeah, we're looking for that perfect balance of low weight, high strength at low cost, which is tricky. And so that's why we're using a special design method today. Using a design method called 5, 5, and 5, where I will create 5 rough versions of wheels, stress test them, then create 5 specific versions of the best wheel from those 5. And then from there, we'll actually even create a better wheel from that. So yeah, that's kind of our goals here, is to keep refining down our designs further and further until we are left with an uncompromised and beautiful design. Oh, I can't quite see Bentley. There we go. Monitors overlapping. Kind of annoying. But the desk is only so big. Oh, this needs to be number 3. There we go. Two keyboards. Alright. Once this JPEG is saved, I can show you our third wheel of the 5 that we're working on currently. There we go. So here we go. We'll whip up the third one for you. This is our third wheel. So you can see some stresses in this particular wheel. This is our radial test, or where we're trying to like accelerate like a drag racer. And in this particular design, we've got some stresses that are a little bit better distributed than our last one. Oh, let me sleep in your clean clothes. Nice guy. Okay. So yeah, you can see some stresses built up in this particular guy, up in this corner here, where my mouse is. And that's not great. That's a tension stress, though. It's not a compression stress. What I don't see, though, on this is much of an equal compression stress, which is good. So we've got some compression over just in this corner here, but it's not quite as extreme as our tension stress there. So that's not bad. It's not a bad design, I guess, if that makes sense. There's still more room to be optimized here, though. So, yeah, this guy's not bad. Obviously, there's way too much meat in the center here. This was done with a little bit of a different profile. So what that was is we had a tapered profile or convex profile of our wheel. So if this is the center of the wheel and you're looking at the tire like this, we had a convex design earlier. This one was a little bit straighter. It was pushed out a little bit further, so it should do better radially, but it may actually flex more torsionally. So let's take a look at those torsional ones. So let's move on to, yeah, this is our radial one still. This is our torsion. This is where we, instead of flexing the wheel this way, we've actually flexed it this way. And you can actually see there is quite a bit more stress in this one. So if we're looking into this guy here, you actually see a lot of buildup at the back of the spoke. We've got a tension stress here and a compression one here. Actually, no, inverse. Let's take a look at the way this wheel is flexed. Yeah, so this is a compression stress on the front. We've got a tension stress on the back, tension stress on the front, compression stress on the back. So this one's more likely to fail this way than it is this way, if that makes sense. So it's still not the best design for us. We were looking for the best one. The cat is wandering around doing weirds. So let's move on to our fourth one here. Hey, jerk. Why do you like the smell of my butt? That cat loves the smell of my butt. If you're going to clip anything from this... Okay, this is the wild one. This is the one we had the weird cutout in. And I have a strong feeling this one's going to take a little bit of time for the computer to go, oh, yeah, no, that makes sense. It's going to take a while for it to calculate. So, that's my guess. Nope, the butt smell wasn't good enough for you? Okay, I get it. No, I get it. You like a different spot. Alright, is it more butt smell over there? I mean, I do fart in my blankets quite a bit, so, you know, here we are. Let's create some fixed geometry now. This one's going to have some trouble with these areas here. This is yeah. It's gonna fail easily in these areas. I can guarantee you here. But that's okay. We are experimenting. Mom, in college I experimented. With what? Stress. But next time your mom asks, you're an engineering student. They're like, yeah, I experimented with stress. Deliver it that way too, like distraught and distracted. That'll probably work out best for you. Cool, let's mesh and run this one. This one is probably going to take a bit longer for the computer to go, no problem. Hopefully everybody out there is hanging out, having a good time. I apologize we're not playing video games today. We are trying to document our process. Mesh failure. Okay, Mesh failed. What? Why did our mesh fail? Let's simplify our mesh a little bit here. So, what's going on? What's the deal here? No, you didn't pop the window up. No.
The air is tight enough to break your lungs like shards of glass. This mud and ice cracks your bones when you
No, escape.
gotta keep on going.
Why are you doing weirds? Okay, it's going to take some fiddling around with this particular file. Only because we put so much detail into it. We're going to find this is going to be repetitive in our part 2 of this, so... We'll see if this fails again. Okay, we're solving it. It's solving. Ooh. So there's 2 parts to stress testing. It's going to create a mesh. So basically it's going to simplify the structure a bit so that there's less to calculate. And then it's actually going to flex that. So it's not perfect. It's not 100% accurate, but it gives us a rough idea of where to kind of focus on. The reality is you do need to build a real wheel and fail it on purpose and then find out where it fails. But this is a good way of starting, so you're wasting as little time possible failing a real wheel. Every wheel that you fail, you have to make a new one. And so you want to only fail 1 or 2 rather than 3,000. And so that's what really the computer stress tests are for, is to just reduce the costs of R&D. Okay, so we have some results here. The results are in! I'm excited that it wasn't too mean to us. Ooh. Okay. I'm very excited to share this with you guys. So give me a second here. That's cool. So this was the wild one that I was playing around with. And I'm actually quite impressed with what happened. So let's record these results. Woo! Hey, Fraxinus, welcome! Oh my god, there's 3 of you coming in. Thanks for the raid. That's okay. Welcome, everybody. If you're just joining in, we are doing a very slow stream today. So I'll tell you now, things are happening at a snail's pace. But we're working on some Miata 3-piece rims. And we're doing it in a very detailed manner. We're trying to find the best way weight to strength ratio. And we're really adventuring with a lot of data. So if it's your first time here, this is not normally what we do. Normally we're playing some video games. Sometimes we'll do some design streams, but they'll be usually a bit more hyper and more interactive. Today's more scientific, if that makes sense. So currently we are doing some aggressive stress testing on some rims. Hi Noodle, welcome. This particular stream might put you to sleep. I apologize. But it is exciting to me, and it might be kind of boring to everybody else. But this is really, truly the type of work that I like to do. Part 1. No. 4-1. There we go. So we're doing some pretty exciting stuff right now, actually. We did, earlier in the stream, we did 5 different designs. Each design being mechanically different. And now we're stress testing them. The one we're working on right now is the one that was the dream in my brain. Was the most complicated of the bunch, but the most abstract as well. So I'm excited to share this here with you. So I have one more test to run on this, and then I can share the results. Sadly, I have to use a separate computer. Can't quite show you in real time our stress tests, but I will share the results with you. So that's cool. Welcome, Bean, by the way. I hope your editing's going well. I want to see video. I will tell you that if you are hanging out and you're bored, you can watch a lot of different vlogs that have come up recently. There is the Stephen Kerr vlog. He's got some stuff about Noodle and I on there. But also the Mr. Fox vlog came out faster than the Noodle vlog. So just saying. So I don't know where these guys are getting the time to edit, but oh boy, they're getting the time to edit. Okay, it looks like our second stress test on our version 4 of our part 1 of our mini series of designing a Miata wheel is slowly getting stress tested here. So, sweet. At any point, if you feel like interrupting me with car talk, you can always interrupt me with car talk. Yeah. But I appreciate the raid, Fraxinus. That's very nice. Oh, I'm excited to see the results. This one was most interesting to me. It was also the lightest of the bunch. I'm so excited to share. This study is currently being solved, says my computer to me. I need a kettle in my room so I can make noodles more often. Excessive displacements were calculated in this model. Ooh. So this one failed bad. Okay, it has to resolve again because it's failed so bad. So what's interesting is it in the first, and I'll share these results in a second. We started with the I guess radial test where we're like trying to do an acceleration, and it actually did really well in that. But now we're working on our torsional tests, and I have a feeling it didn't go so well. So we'll have to make some improvements and changes to that particular design. But interesting enough, it was our lightest one. So weirdly enough, in our radial test, even though it used the least amount of metal, so far in all the wheels we tested, it was the strongest. So it might be worth making some changes to. We'll find out. I might have a bias as well. So I want to really see how it failed torsionally, and then that should see where we're at. Cool. Oh, it's taking a while. Meow. Meow. Bentley, you're missing your opportunity for snugs, by the way. This wheel, some of the fillets I did actually probably made this wheel weaker than stronger. In some places, fillets would, in areas of compression, fillets would make things a bit stronger, but in areas of tension, areas of tension like ribs, weirdly enough. But that's, don't follow that statement as wholehearted. That is, I would say that's a 30% truth, at best. Okay, finish. I'm ready. I want to see the results. I want to see our massive failure. I have a strong feeling that there is, where we were talking about earlier in the stream, where there was sort of a very sharp fold in the metal. Folds are usually bad. That's where there's going to be the most amount of failure. And we can actually redraw this wheel if we need to like get rid of that fold and retest again. So I'm excited to find out. I'm also really hungry. Come in. You can do it. I believe in you. You can do it. It's struggling. Ooh, she's struggling. Ooh, she's struggling. This particular design was tricky for it. It's like, I'm at 100%. I don't know about that. You haven't finished yet. Okay. Well, I don't know what the computer was complaining about, because the results actually are really simple and easy. It's amazing. Okay. I doubted myself for a second there. You caught me on camera doubting myself because the computer doubted me. All right, let's save this as JPEG. I am so excited to share this with you guys. Give me a second here. Go. No, no, no. Okay, let's add one more screenshot to this because I think there's some more investigation to be done with this particular design. So, I wanna record our results a bit more, if that makes sense. And I have the freedom to do so. Okay. Okay, so let's do it. Let's share. So this was our fourth wheel. This was the one that we had. I was just like, this is my wild dream. I was up in the middle of the night. Thank you, Nick. I appreciate that. Yeah, so we're working on to catch you up where we started. We started with five really crude or basic designs of spoke shape, and now we're on the fourth one. We're doing some structure testing. So we designed them all. Now we're structurally testing them all, and we've structurally tested 4 of the 5 so far. So this here is design number 4. This was the lightest of the designs. This is a deformed look of it. So if you're looking at it right now, it is deformed. It is misshapen. But here's the thing. This was the lightest center that we designed. Of all of them, this was 1,300 grams. But you'll also see that we haven't even reached the stress levels that we met on some of the other designs. So we've got some general stress collection here as tension, and our compression stress here is not super aggressive either. So this is actually dealt with the stresses better than some of the other designs. But let's take a look at so this is the radial test where we spun the wheel like a dragster, like leaving the line. So but we also have the Formula One car going around the corner where it's not just the dragster, it's the torsional flex. So let's take a look at the torsional flex here. I'm excited. I thought this was good. Like the computer's like, there's a big problem. We gotta it was actually warned me, but take a look at this. Our torsional flex is extremely minimal. So far, this is actually the toughest design. So this is some tension here on those spokes. I do want to get into, I'll take another screenshot here, just because I didn't capture the compression stresses. Kind of looks like a throwing star. When we stress test stuff in SolidWorks, what it likes to do is it likes to take things and twist it for you, and it exaggerates it so that when I see the results, it's not like, did it twist? No, it definitely twisted. I can see there. So that unevenness or the asymmetrical look of it as spun is not how the design normally goes. But yeah, give me a second here. That's exciting. There we go. So I'm actually really excited with this design. We're gonna have to look at more of this. We're gonna stress test our final wheel, our quick fake Watanabe. It's very quick and very fake looking. But I will show you one more screenshot. And I think this is where the confusion came with the computer. Is we had that little fold that was underneath that we could design out of it, and that's where we're having a lot of stress build. This is under compression stress too, so that's a bad stress for us. And so, yeah, this is where that fold was, and it's actually a result of one of the fillets I added. So we can actually take the fillet out, make the wheel less complex, and it actually be stronger. And so that's kind of exciting. I'm excited. I'm having like my full autism splash. Like, yeah, the phoenix has risen, which is a really weird reference that you guys won't understand. But yeah, this is exciting to me. I'm really excited because this wheel actually is light and strong. Okay, let's get into our stress testing, our very final wheel here, and then we'll do a bit of a review of where we're at. Okay. My call isn't complete. All right. I hear you. I hear you. Why don't you hear me now? Okay. This man is chewing gum and singing at the same time. Again, we're going to test this wheel with 10,000 Newton meters. An extreme amount of force. We'll find out. Oh yeah, yeah, full autism. Light, strong, small, all. Yeah. That's really what I want, though. Is if I achieve those goals and I can do that consistently, people are like, "Hey, Quinn, you gonna design a wheel for me? Hell yeah, let's do that." You get the phone calls when you do the good jobs, so I want the phone calls. I could be making the pizza for the people, or I could be making the wheels. Okay, so we've got some results from our final design here, our Watanabe. I'll capture those results for us, and then I'll share them with you, just like all the other wheels. It'll take me a moment to get that all did there. So our first test is done. Dude, this guy's singing is wild. It really sounds like his cheeks are really heavy. They're really heavy cheeks. Wireless keyboards are weird. Just saying. Okay, let's do our final test on this. So we've got our radial test done. Let's do our torsional test, I guess. Still don't really know the right names for these, but language transcends the spaghetti. Okay, let's do this. This study is being solved currently. Some of these songs are okay. I'm not gonna lie. Some of them, they're enough that I'm jamming. But nah, I haven't had any big hitters. Oh, this one's struggling to do some of the, yeah. I feel that warning's generic. It's like, hey man, this thing's gonna really fail, and I'm like, you said that on the last one, and it was great. And it's like, it's really gonna fail. I'm like, all right, send it. So it's gonna take a second here for it to calculate it. Mow. Mow. I wonder... Yeah. Oh, I'm excited. This feels fun. This is fun. I'm actually stoked. Full autism. Love it. You can do it, little computer. Whir and buzz. Buzz and whir. You know what's funny is I bought my fancy new computer to do these calculations a lot quicker, and it just refuses to install that software. It's like, nah. I'm like, okay, cool. I guess I'll never do that. I guess I'll use the old computer that I tried to replace. All right, we've got some results on this torsional test. So we'll capture those. let's save this whole darn document. Alright, I'm going to share this with you guys, just so you know what's going on. So here is our Watanabe-like wheel. Not exactly Watanabe, but it's Watanabe-like. My brain is loading. Okay, so we've got some tension points here, and we've got some compression points. So you're going to see a lot of tension, so pulling in the spokes just down here. Those are a little bit greater than our compression force, which is a really good sign of decent strength. And you can see it sort of collected in the corners here, which is expected. I know it's not quite a Watanabe, but I wanted to show sort of how an 8-spoke would work. I know, it's not really a Watanabe, I get it. But yeah, I just want to see how it would structurally test with an 8-spoke design, a round 8-spoke design. So yeah, that's our twist test. That's our torsional test. Let's look at our torsional test actually, which is our next one here. So this is still our twist test or our radial test. Here's our torsional test. So we've got some collection of stresses by the spokes. Not bad though. Did a pretty decent job. This song's okay. I got excited. There was a good drop, and then no, shit music. Okay. Yeah. So this has some compression tensions and or compression stresses and some tension stresses. Nothing too violent or too wild, but yeah. Okay. We're gonna copy this. So that is the first part 1 of our 5. Whew. So once this is copied over, we'll do a bit of a review here. We'll take a chance to sort of see what's going on, what seems like the best direction to follow from the 5 designs that we did, and then we'll start working on part 2. Well, I might need to take a food break. I'm getting a little bit hungry. Eating food's pretty good. Those of you who've been hanging out, good job for sticking around. Thanks for hanging out. I'm flattered. It kind of, it's funny, I've got the let's and boring car style into there, but I mean, this is I'll be honest, this isn't the most exciting stream to everybody. For me, it's exciting, but maybe not for everybody. So, let's kind of boring car style today. Cool. Not everything went over. All right. Oh, you know what? Yeah. Okay. Eat. All right. So I want to look at our stress tests here. Okay, no, I'm out on the song. See you later. Nope. No British rap. We have rules on this channel against British rap. All of it's illegal. All right. Actually, that was dumb. try this again. File new. Oh, why? So bad at Photoshop. Okay. Why is number 4 up at top? There we go. Okay. Let's take a look at all these guys. Let's do a bit of a review here. Yeah, Photoshop's annoying. I can't agree. Let's just do a quickie like this. Yeah, this will be good. There we go. Alright, so we're going to put our version 1 up in the top corner here. Great. Good job, Photoshop. 0%. Go. Version 2 up there. Yeah, no. There we go. Version 3. Same problem. Version 4. Go, and then version 5. So these are all our stress tests. Part 1. -1, there we go. And then I'll hide all those guys. This song's good. This one's dope. Big fan of this guy. Did I not upload? Oh, I didn't upload the right ones. That's right. That's okay. File save as JPEG. There we go. So let's take a look at these together. A song sung by Melinda Trump. Okay. So just looking at the bunch of these, weirdly enough, the strongest one was our experimental one. So we've got version... Oh, you know what? We can edit these a little bit more. Let's open these up a bit more. Well, so much wubbin. That's why you come to my channel, for good wubbin. Considerate wubs. You know, he's a really nice wubber. Very considerate wubber. What am I doing? Alright. We got V1. That's my favorite restaurant, McWubbins. Oh my god, the wubs. Mom, help. Mom! Mom, help! There we go. So yeah, we've got our different versions here. Whoa, is this Banks? I want to take you to the movie, shorty. And to have a good time. Oh, there's more wubs. We're getting wubbed at. All right. So let's take a look at our stress tests. Cha-chung, this is the grand finale of part 1. Tung tung. Now we have a couple of things to look at here. Our just basic cross here. So version 1 or V1. Distributed stress is pretty good, although you see a lot of stresses going into the lip, and there is a lot of stress collection at the bolt holes. But that out of the grand bunch of them, actually distributed the most force out to the lips, which is neat. That's very neat. Version 4, though, dealt with the stress the best, weirdly enough. If you're looking through this and you're interpreting this, let's figure out how to interpret this. So the higher the level of red, the more stress is occurring. And the lower the level of the red, the less stress is occurring. So, yeah, you can actually see there's quite very little stress happening on version 4s. They were also our lightest wheel of the bunch. So if we go back to our stats here, you can see that our results, our part 1 results are showing that our version 4s had the lowest weight, just on average. Our version 5s actually came in second in the weight there. So let's take a look at version 5s. He likes V3, he likes V4. Awesome. I think I'm automatically like leaning to version 4, which was the weird rim I was dreaming of in my brain the other night. So yeah, the version 4s are really getting me hot and bothered. They're also the ones, so if you weren't here earlier in the stream, let's take a look at the complexity of the version 4. So the version 4 actually has an underspoke. So you can see we've actually cut out the material underneath the spoke, because that's material that doesn't actually add to the strength. It does need some further refining in order to be usable. At this point, we can't really press in. We can't quite press in a lug seat to make this work yet. But so far, our version 4 is 1, the most complicated, but 2, the strongest of the bunch. And so our part number 2 of this sort of design series, yeah, this is where it gets. That's why I was like, whoa, these might fail. But yeah, that's actually cut out underneath. And so this was the rim I was dreaming of in the middle of the night. I was sort of laying in bed, just sort of mulling over this project before starting. And I really wanted to create a spoke that distributed forces a lot differently than usual. And so I feel like we've gotten those results in here. Hey, welcome, Fraxness. So to catch you up, we have just created 5 different wheels. The part 1 of our Miata wheel design is designing a 3-piece wheel with the lowest weight, the highest strength, and fits the most affordable lips that we can get our hands on. So we have been designing to these lips, and so we did 5 different designs. We stress tested them both radially, meaning spinning them like you were to accelerate or brake, and torsionally, like you were turning very hard. And these are the results from that. So we had a version 1, the Rhoda Slipstream. Yeah, I'm not gonna. I have opinions on that, and I'm gonna maybe save those for in private. There are some good Rhodas. I will say there's some good Rhodas. You just have to be careful. Yeah, so we did a bunch of stress testing, and weirdly enough, the one that was the most wild of the designs with their undercut spokes here was actually the strongest of the bunch. To interpret those results, you can kind of tell by the colors going on here. So red is bad for us, and so you'll see some areas where stresses have built up on these wheels, where you can see that the red has sort of maximized, especially on our version 2s here. Let's dial this back a bit. So you can see some stresses built up on our version 1s and version 2s. Our version 3s, yeah, we saw some stress. Our version 4, we do see some stress, but it's at much lower levels. And then our version 5s, sure, Watanabe-esque, had some stresses there as well. So that's our radial test, where we're spinning them like a dragster, leaving the line. Then we had our cornering test, and yeah, we can see some stresses delivered to these ones as well. But overall, it looks like our version 4s, which were the lightest, dealt with the stresses the best. You can see that the rim barely even deforms or struggles there, where in some of the other ones that a lot of that's delivered back to the rim. So we also don't see very high levels of stress. We don't see a lot of collections of stress here. So it's neat to know that, yeah, we have possibly a design to follow. Yeah. So if you're wondering, that was our part 1. We're just doing a bit of review here. So our 3-piece Miata wheels, we're doing a 15x8, 4x100, plus 25 with a 54.1 millimeter bore, center hub bore. We're using an extra small face on this one. The reason being is we're using motorsport specific barrel or lips on this, which may not be the prettiest lips. I'm going to put that away. Not pretty lips like these ones, but we're going to be using some N8 hardware, and we're going to do it sandwich mount. So these will not be a welded lip set. It'll actually be 2 separate lips, and you can interchange them as needed. But we're using what's called the 555 design method. We're creating 5 wheels, stress testing those 5 wheels, picking the one that works best, building 5 more versions of that one, we're going to stress test those again, and then pick the best version of that, and then we're going to build 5 more wheels and try to get the aesthetics on that third sort of build structure. We're hoping to get the aesthetics. Make the wheel look really good. So we're going to build 5 wheels and sort of style them differently to finally get a really good look. So we're going to do form first, we're going to do function first, and then we'll do form, if that catches you up. So yeah, our checklist here was to use some brake measurements to make sure we clear. Earlier this morning, I actually called the company that makes the lips and got some clarification. You can see that a little bit earlier in our stream. We created a rim profile diagram, and we created our template. And then we built a bunch of wheels from it. So we can actually do this. We can copy this boy, and we can say check mark. We did part 1. Now is to pick a wheel from part 1 and decide where to go from it. I might take a break here. Although you just joined us, I may apologize. I might take a bit of a break here, go get some food, maybe bounce some ideas off some friends, and then come back and really commit to doing 5 versions of that particular wheel. It's likely it's going to be version 4, but I'm going to go through the results a little bit more and dig in a bit better, and then we'll go from there. But if you've been hanging out with us, awesome. Thank you very much for hanging out with us. Maybe we'll even play some games later tonight. I think that's probably enough of the wheel design for today. We've probably been at about I would say we're been at it about 4, well, no, even longer than that, probably about 5 or 6 hours now. So yeah, it might be a time to take a break from it, even though only about an hour and a half to actually about 4.5 hours of it streamed. I did some stuff off stream as well. But yeah, thank you very much. Sweet. So I will talk to you guys later. If you want to scoot back in the stream and see how things progressed, you can do that too. Sweet. But we'll be back again probably maybe tomorrow morning. I got some students to teach. I know tomorrow's Tuesday. It should be back on Wednesday for sure to continue where we're left off. But that'll give me some time to think about really which one of the 5 I really want to follow through with. And it's likely number 4. So, but if you've been hanging out with us, thank you for hanging out with us. And we will talk to you later. Maybe we might even put in a little bit of a video game stream at some point in between. But yeah, anyways, please have a good evening. Eat well, and top sports. Top sports. Bye.